we are talking about increasing and decreasing, and on the Desmos you saw those intervals on the side. Those intervals, if you kind of really paid attention, it was showing like, you know, you had your highlighted portion, it showed this x value, comma, and then it was this x value over here. So that's what an interval is. An interval gives you like where you're starting to where you're stopping. You use an interval when there are too many numbers to list separately. And like, you know, we saw there's lots of decimals. You didn't have just whole numbers. So you could never literally list every single decimal value, even if the chunk was really small, like that's infinite. So that's why we use an interval. So an interval, you have one number. The first number is your start point. The second number is your ending point. And as we saw, a function is increasing.
I got a question.
I haven't decided yet.
Hold on, every notepad book too?
Yes.
Yeah, you better know.
Alright. A function is increasing if the y values get, what do you think would go there?
Move.
Nope. If the y values get
Increase,
bigger.
Oh, same thing.
So as you go left to right, if the y values get bigger and your line literally goes like up like that, that is increasing. A function is decreasing if the y values get smaller. So if your graph is going down like that, that is decreasing. When we write our intervals, we only, for increasing and decreasing, this is just kind of the rule, we only list the x values. And you saw that on the Desmos, it only had the x. Like when you drug the point, it said x equals this. That was the number on the interval. Now we know that when we graph some of these, sometimes and if we have an arrow on the left, we're going to write negative infinity. If we have a right arrow, we're going to put positive infinity. And that'll, once we get to an actual example, that'll help make a little bit more sense. But anytime we have an arrow, that means it goes forever. So you really couldn't pick the actual starting point. You don't, it goes on forever. So we put, if it's the arrow on the left, regardless of if it's pointing up or down, if it's on the left, we use negative infinity. If that arrow is on the right, regardless of if it's up or down, we use positive infinity. Okay. Turn your paper sideways and draw an 8.
How can there be a negative infinity if infinity just means endless?
But it goes endless in the negative direction. So like negative 100, negative 1,000, negative 1,000,000, negative 1,000,000,000,000. So normally I would have you graphing these on Desmos, but I'm just going to today to save some time. Okay. So we're going to graph these. Now on your phones, you can, I just Googled Desmos graphing calculator. So if you ever needed it, it's up. You can do that. But I'm going to type y equals x cubed minus 3x squared. And we're going to graph this the best that we can. So I'm going to tell you what these max and mins are, and we're going to plot those. So the first one, we have a max at, looks like 0, 0, yes, 0, 0. And I want you to write that coordinate, or really we could just put x equals 0 there. Because that's all we care about anyway. So x equals 0. And then the other one is at 2, negative 4. And I'm going to put x equals 2 there. And then just going to sketch the rest of it in. It doesn't have to be perfect. So we're going to list the intervals of increasing and decreasing. Now on the Desmos we did, you kind of just picked any little chunk that was increasing and that was okay. We're going to give the full interval. We're going to show the whole thing. So when I start tracing my graph, I'm going to use this purple highlighter. When I start tracing it, am I going up or am I going down? Going up. So this first part is increasing. Where would I say that I start? What do I?
Above the 0.
Okay, what do I actually start on? What's there?
What's like negative?
What's at the end of this line? An arrow. It technically goes on forever, right? So I really could not pick a starting point. That arrow is on the left side, so I'm actually going to start because it's an arrow. Like I literally cannot pick the true start. It stops when it gets to this hilltop or this maximum, which is what number? I've climbed up to the top of the hill, and now I'm rolling down the hill, so I'm going to start decreasing. So I'm at 0. Up at, what's the x value? The x value of 2.
That's because it's normally x and y.
Confusing because this looks like an ordered pair.
Yeah.
It gets confusing, but when we're talking about increasing and decreasing, we know that we're writing an interval, meaning we know we're writing starting x, ending x. Okay, now when I'm down here at the minimum, I'm in the valley. What happens? You make it, you're down in the valley, we increase. So where am I? I'm down here. What's that x value?
2.
2. Let's do another example. Again, normally you would be graphing negative x to the 4th plus 4x squared minus 2x a maximum negative 1.5. So go to the negative 1 and then close to 4, 5, 6. So, I mean, your point's so big that as long as you're in the correct area, it's fine. So I'm going to put x equals negative 1 point. I'm just going to put 1.5. That's okay for right now. I won't be too picky with your rounding. And then we have a minimum So it's 0.3, so go just a little bit past the origin, and then down 1, 0.3. And then we have another maximum at, so it's like 1.3, so it's just a equals, oh shoot, 1.3. And that's what it looks like. So when I start tracing my graph, is my line going up or down? If I trace it starting,
It's increasing.
Yeah, even though the arrow is pointing down, if I'm tracing it, I'm still tracing it going upward. So we still call that increasing. So where does it start increasing? Negative infinity, because that arrow is on the left. Not because it's pointing down, but it's on the left, so it's negative. All right, and then where do I stop? Negative 1.5. And then what happens after you reach the mountaintop? You go down. So it decreases from negative 1.5 to and then I increase for a little bit. Where do I start going up? 0.3. Where do I stop? 1.3. And then I go down. Where do I start going down at? A lot of you will want to put negative infinity because the arrow's pointing. So I don't care if it's pointing up or down. It's on the right, and it is slightly deal with left and right. That's what we're talking about. The y value. Let's do y cubed plus squared minus 4x minus 1. Okay. All right, we have a maximum at the coordinate negative 2, 7. Up 7. 2, because that's the only thing that I care about right now. Not 7, which is not quite yet at 1, and about a little bit more. Increasing or decreasing? Increasing. It's just been coincidence that all of these have started increasing. So, where does it start at? Negative infinity to what? Increasing to what? 0.7. And then I'm in the valley at 0.7 and I do what? Increase. So from 0.7 to good. Infinity. Number 4. X to the 4th minus squared minus 2x plus 3. Minimum, so it's negative 1 and then a little bit more, and then it's about 1.7, so about right. 0.3 there. Negative 1.3, yep. And then we have a maximum. About like that. Again, I'm not going to be counting your blocks. All right, and then 1. Negative almost 4. And it looks like that. So when I start tracing this graph, what am I doing first? Decreasing. Where do I start decreasing?
Infinity.
What'd you say?
Negative infinity.
It is negative infinity, even though it's point. About to where?
So 1.
And then I'm down in the valley. Now is where I start. Negative 1.3, sorry. And then I start negative 0.3. Good. Now I've made it to the top. Now 0.3, and I stop at
Negative infinity.
nope, I stop at 1.5.
I didn't put that one.
From 1.5 to negative infinity. Very good. I'll let you do number 6. Number 6. Get on your Desmos graphing calculator. X cubed.
Automatically do mini scientific. The number on the right left. It's only part I didn't give out.
No, it's the one. That's the first one that you do. So 0, 2. But I only put like that, so you just put X equals 0. Yeah. And then this one is like 1.3, so you can go a little bit faster.
Oh, yeah.
Well, the only. Yeah. Yes. Okay.
This one never decreased. Hey, does number 6 decrease?
Yes.
So if I don't do the other one?
You have 2 increasing and 1. No, the only numbers you need to write down are any of the.
Yeah.
0.8. That's a Y value.
How do you know?
That's just an x-intercept. So we don't. The only ones that we. It increases on past that. So that.
Keep it going,
Good.
I was recording the whole time.
See, though, even though